Hello, um, my name is Amir Mehdi. I'm making this video going over my project for the Gen AI course in the capstone project. So my project involves creating an agent that's going to help data scientists with EDA and modeling and research. So whenever a data scientist is presented with a machine learning or prediction challenge or task, typically what you would start by doing some research to gain some kind of context, main specific context around that problem. You know what things could be predictive of the thing you're trying to predict. For example, you're trying to predict the stock market for a particular stock, you need to figure out what kind of things up or down the stock value for that particular company. Here, I've decided to create an agent to help with that. And I've broken it down into two agents, essentially. One is the researcher who goes, searches the web, and comes back with a comprehensive research report about everything that you might need to know for this challenge, for this prediction challenge. Comes back with feature engineering ideas, EDA ideas, modeling ideas. And then finally, you'll have a data scientist agent who's going to take that research report and perform multiple steps of analysis. And so in this particular case, since this project was on Kaggle, I was decided the best way to evaluate this agent is to run it on Kaggle competitions. Inherently, prediction tasks, most of them. So that's what I'll be demoing and going through Kaggle competition, in particular this one. You're not seeing this tab, but this is the Space Titanic competition. Fun. So as I said, we have a research agent and a data scientist agent that will go in depth about how these two agents are going to look like. Here we set up our libraries and packages that we're going to need. We're going to use LangChain and LangGraph for our agent development. We're going to use Google Gen AI platform, use Gemini as the LLM of choice here. I've also decided to use Tavily, which is a tool to allow LLMs to perform searches. It allows you to do dynamic web searching and things like that. So here I'm setting some secrets for the API keys. And okay, let's get to it. So the first thing we're going to need to do is to define our agent state. So what this is all the different variables we either going to give as an input to our agents, or these will be intermediate steps that our agent is going to manipulate and update, or it's going to be the final response, or a list of messages that our agents use to communicate to each other or the user. In this case, our inputs are going to be the competition description, data descriptions, all the data we have access to, a list of paths to the data. So in this case, train and test data that the agent can load and look at and do analysis on. It's going to be a research report. So this will be the container for the research that the research agent is going to be conducting. And it will save that research report in this container, in this state. And then we have a Python state. This will be kind of a simulated sandbox environment that will contain all the local variables and functions and things that the agent will use to run the Python code for its analysis. And we'll see kind of how that looks like. And here we'll define our states. As we talked about, we're inheriting from a message state. So what this is has a list of messages, chain messages, that allows the agent to kind of communicate messages to the state, to have this kind of chat-like interaction. All right, let's talk about the researcher agents. We're going to define a prompt for our researcher. This is kind of a comprehensive prompt to provide to the agent. It's objective. Tell it, it's going to go search the web for relevant contextual information. Inputs it's going to get, and what workflow we want it to follow. That the research is what we want it to be, and kind of the deliverables and the guidelines for the research is going to perform. And here we have some template inputs. So the competition description and data description will be the input to this agent, as well as the list of messages. We're going to define a kind of class for our research report, so we can have the model provide this research report in a structured manner to us. And finally, we're going to define our agents using a React agent. So this is a pre-built agent that is going to first reason about what steps it's going to take. So in this case, it's going to be what tools it's going to call, perform those actions or call those tools, observe the response of those tool calls, and kind of continue, iterate on this, all the steps, and finally respond to the user when it terminates. In this case, the only tool it has access to is the search tool from Tavily. It's going to allow it to search the web. And the LLM is Gemini 2 Flash, giving it the system prompt, giving it a name, and providing it the state schema. And that's going to be our agent. This is going to be a LangGraph graph, which has an agent, a tool node, and a loop between those two nodes. Finally, we're going to have a node to extract the report that the agent is going to write and add it to our research report container in the state. We can refer to it in the future steps. Here we're going to define a simple graph which has two nodes, the research node and the extract report node. And this is what it looks like. So we have our research node, which is this React agent, the agent and the tool nodes, and then finally the extract report. Okay, let's run this. So here I have copied the competition description and data description from the Space Titanic competition, and I have implemented a helper function here to simulate the graph and the agent. We're going to stream the agent, this input. And then here I just have some ways of displaying the agent tool calls, tool responses, and its kind of messages. So I'm not going to get into details about this, but it's just a utility function to display the intermediate steps here. So I ran it before, but let's try to run it again. So we're going to run it on the competition description, data description, and we're going to ask it to perform the research. And it's going to first think about, read the research competition description and think about, create some summary about the competition. It's going to perform the tool call. So it did 3 queries, space travel, demographics, cryo, sleep risk and benefit, blah, blah. And these are the links that it pulled up from the web. And finally created the research report for us. So the competition summary, domain understanding, feature interpretations, some hypothesis, strategy suggestion for modeling and EDA. Some links that it's used for this research. Cool. That's, within seconds, we got a research report about this competition, and we can get started on the EDA and these recommendations for the modeling. Okay. Then we get into our data science agent. So this agent is going to be similar to our search agent in the way that it's going to be a React agent. Only difference is the system prompt and the tool it has access to. Here we're defining the system instructions for this agent, and we're telling it it's a scientist or a data scientist helper that it's going to help with the EDA and modeling part of the competition here. It's going to get the competition description, data description, all the file paths it will use to load the data and the research reports from the research agents. The tool it has access to is this execute Python code. So if you look at this tool, it really has two arguments, code and output key. These state and tool call IDs are just injected into the tool for us to have access to the state variables when this tool gets executed. Also to be able to update the state after this tool gets executed. But the LLM sees code and output as the only parameters to this tool. So it's going to write this Python code, and it's going to tell us which variable in this Python code it requires to see the results of. So we can kind of parse that from the code, executed code, and show it the results. So it can kind of perform the sequential analysis. And so not going to get into too much details here, but essentially what we have here, we initiate some space for the agent, some global and local variables that it can run code on. We're going to use exec here to run the code. After this gets executed, the globals and local variables will get updated here. We have access to those variables. Keep in mind, this is not safe. Technically, the LLM could run any code. So you don't do this in production. You want to add a lot more sophistication here to make this secure. Not let the LLM run any code, hack your computer, get access to your bank account information, buy some GPUs, and clone itself across the world and take over humanity. Be responsible for that. So be careful here. Proceed with caution, and make sure you add safeguards and kind of restrictions here as much as possible. But one thing you can do, you can limit the pre-built functionalities the LLM has access to here in the globals. So you can provide it some list of pre-built functions and modules that you have installed. The LLM can only use those, and else you're restricting its world. So we're going to execute the code. We're going to parse out the output, and we're going to provide it the results as a tool message here. Command will let us update the state. So we're going to update the Python state with all the persisted variables here that we have pickled to make sure they're serializable. And also based on the output key that the LLM has told us, we're going to parse that out of the local variables and provide it. We can look at the results and continue. That's it. So this is the tool that it has access to. And the agent looks very similar. The code looks very similar to the previous one. We're going to create this React agent with the LLM, the tool, system prompt, name, and it gets created. Now let's run it. So here we can see I'm giving it the research reports from the previous step, and I'm asking it to perform EDA and modeling. Let's see if this works. So it's gonna perform its EDA, it's gonna run this Python code to look at the data. It's gonna keep doing few stuff, visualize, processing, and do a model training here. And I think the results are going to be printed out in the end here. Yes, so you can see all the results, the visualizations it did, warnings, and we got a 77% validation accuracy on the first try. It literally took a few seconds to do. So you now have a baseline to go from. Gave us some suggestions, next step recommendations. We could rerun this agent, ask it, perform these recommendations yourself. improve the results. We can just do it ourselves. And yeah, that's it. And then I guess we can also put the two agents together. So it's a more fully automated workflow going from research to the model here. All we need to do, create another flow. We're going to add the research agent and the data science agent, connect the two with an edge, and compile the graph. So the full agent is going to have the research agent does the research, we extract the reports, and then we go to the data science agents to do this analysis. One thing we can do here to make this a bit more robust, we can add kind of a supervisor here to orchestrate different steps. So maybe the data science agent starts to do some analysis, and it's like, okay, I actually need to do some more research because I hit some rock bottom. So then you can have that kind of back and forth communication between the data science agent, the research agent, and go from there. Yeah, and we can see that we can run the full agent here. So the only difference is I'm not going to provide the research report anymore. I'm just going to give it all the inputs and ask it to just help me with this competition. Make sure you use a tool to perform the analysis and train at least one baseline model. I'm also going to increase the recursion limit of the graph, so it can perform more steps before hitting the limit. So let's see. Obviously we're going to get a different answer this time. This is an LLM. So I ran it once and I got a 90% accuracy. It did some smart stuff. So it's not smart all the time, but sometimes it also doesn't call the tool, just gives me the Python code. So that's something we can improve upon, like this time. It just gave us its thought process as opposed to doing it itself. So we can probably do some more prompt engineering to make sure it calls the tools. Let's run it one more time. It did the research. Let's see if it does the modeling. Okay, it did. Nice. And we got 75%. It's doing more analysis now. Yeah, that's all. Thank you.